Okay, so this brings us on to our next topic, which is properties of covalent bonds. In particular, what we're looking at right now is simple covalent molecular bonds. Okay, so simple molecular covalent substances. Now, these include things like hydrogen gas, so this is a gas, methane gas, this is a gas, oxygen, which is a gas, and liquid, which is a gas. All of these are, of course, at room temperature. So at room temperature these are gases, and at room temperature water is a liquid. Now, because these are gases and liquid at room temperature, what that tells you is that they have a low melting and boiling point. But the question is, why do they have a low melting and boiling point? Because covalent bonds are quite strong, and this is a representation of methane, CH4. Now, the bond between the carbon and the hydrogen, this bond here, is quite strong because it's a covalent bond. So covalent bonds are generally quite strong. So it takes quite a lot of energy. And so what do we mean by it's quite strong? It will take a lot of heat energy, to break these bonds. If we're saying that it's going to take a lot of heat energy to break these bonds, the question is, well, why is it actually having a low melting and boiling point? Why does it require a little energy to break these bonds? And the answer is because of this bit here. You see, it's the bond between the methane molecules that are quite weak. It's like having these two friends, friend A and friends B, right? And friend A has a good personality, friend B has a good personality. However, the friendship between them is quite weak. So basically, that relationship can be broken quite easily. And that's one analogy, I suppose. Now, this is known as the intermolecular force. Okay, but you don't need to know that. All you need to know is that the force is between the methane molecules, or the oxygen molecules, or the hydrogen molecules. So the forces between the methane molecules are weak, and so because they are weak, it requires less energy to break the bonds, to break the force of attraction, or to break the force between the methane molecules. So it's quite easy to break this bond here, and so because it's easy to break that bond, it has a low melting and boiling point. So again, just to recap, methane itself, between the carbon and the hydrogen, that's a covalent bond. Those are quite strong. However, the weakness comes in the forces between the molecules. So the force between the molecules are quite weak. They require little energy to break those, and so it's overall got a low melting and boiling point. So next point is over here. So we're kind of done with this side of the board, if you like. We're going to look at this side here. Now remember, this is our diagram, our cross and dot diagram for our methane molecule. Now, as you'll recall, or as you should recall, carbon has a full outer shell because of the covalent sharing. So carbon has 2, 4, 6, 8 electrons in total, and hydrogen has 2 here. This hydrogen has 2, this hydrogen has 2, this hydrogen has 2. So hydrogen also has a full outer shell. And this is the same for hydrogen, methane and oxygen, because they are all simple covalent molecules, and water, in fact, because they have a full outer shell, none of the electrons are free to move. None of the electrons are free to move. And of course, you should know that the movement of electron is what causes electricity. So if none of the electrons are free to move, what this means is that they cannot conduct electricity. conduct electricity. Right, and so that summarizes the properties of simple molecular covalent substances. So now we got to look at the next one, which is giant molecular covalent substances. Okay, now giant covalent molecular substances are different to these simple ones. Okay, and I'll explain how. So this is giant molecular covalent substances. Now I have seen in one of the foundation exam paper they've asked you what is, so that's 1, 2, 3, and then something like, it'll be something like this. So 1, 2, 3, 4. So they all have 4 bonds each. I'm getting lost in my drawing. So if you take this one here, it's got four bonds. So 1, 2, 3, 4. Right. That's the simplest way I can draw it. Now, what is this, guys? This is a giant molecular covalent structure. This is actually diamond. Okay. Now, with diamond, all of these are covalent bonds. Okay. So look at how much covalent bonds it's got. Got loads and loads of covalent bonds. And like we said, covalent bonds are extremely difficult to break. Now there are no weak forces here. This is pure covalent bonds. Okay, so because it's pure covalent bonds, now the question is, what do these circles represent? These circles represent carbon atoms. Okay, so what you've got is you've got loads of carbon atoms that are covalently joined together, and because they are all covalently joined together, and there's no there are no weak forces between the atoms, this will have a very high melting and boiling point. Right, which is good. And so this is going to be very strong, and it will require a lot of heat energy to break those bonds. Right, so that explains why it's going to have a high melting and boiling point. Next, the second giant molecular covalent structure is graphite. Okay, i.e. your pencil lead. Your pencil lead is not made of lead. Lead is toxic. Okay, it's made of graphite. And so graphite, if you think of your pencil lead, is much softer. Right. So graphite is much softer, and it's because it's made up of carbon atoms, right, that are covalently joined together. However, unlike carbon, right, carbon, if you saw, it had all that very strong structure. With this graphite here, it's actually made in layers. Okay, so that's a top layer and a bottom layer, which makes it actually quite soft. But because it's made in layers, this is what makes it soft. And those are really the things that you need to know. Okay, and so this here is, these again represent carbon atoms. Another thing you need to know about, so you've got 3 giant molecular structures that you need to know about. Number 1 is diamond, that we covered just previous to this. Number 2 is this, which is graphite. And number 3 is sand. Okay, so that's what you need to know about simple molecular covalent structures and giant molecular covalent substances. And that concludes this video.